Okay, this is GeoVisionary version 2.5. GeoVisionary is an advanced visualization for users to load and visualize and inquire into multiple different formats of GIS data. So it can be above the ground, on the ground, under the ground, and the whole idea of GeoVisionary is that you can load it at 100% resolution. And the data can come from all different kinds of different formats. So as we know, there's lots of tools out there producing different formats, and we want to see the relationship between those data sets. So GeoVisionary is a partnership between Vitalis and the BGS, the British Geological Survey, which is the British equivalent of the USGS. And we are partnered on this project as a team, and we've developed it together, and it is really originally a geological toolkit that now has been opened out now to users in hydrology, geoscience, flooding, mining, oil and gas, geomatics like road building, rail building, pylons, laying them out, pipelines, urban developments of the civil engineers. And if you want to see something and what it's going to look like before it actually gets built, and you're still at the planning stage, then this is a great tool to visualize all this kind of data. So I'm going to free fly in now. What we have here is a 5-meter DSM, so it's a surface model. You can still see the lumps and bumps of hedgerows and trees and man-made objects into North Wales. As you can see, you can apply a gradient to it, and in the new version of the software you can apply a gradient to any object that you load. So you will notice that there are some dark areas, and these dark areas are because of the source light, and because of the angle of the sun and the steepness of the slopes. And what we can do is we can turn these around. It's like a 12-hour clock, so you can pull the features out of the darkness. Now you can put horizon bands, apply horizon bands and visibility restrictions to this. I've turned them all off, so you can see the fact that Scotland is there. In this model, this 5-meter elevation model, it's about 75 billion triangles, and I'm able to run this off a laptop, a Dell Precision 6800 with a K41 NVIDIA graphics card with 4 gig of RAM on the actual card. So I might want to turn on imagery for the whole country. Boom, takes about a second, no problem at all. And you can see it is for the whole country. I might want to change that with a map. That's how quick and easy it is. You can load 50 plus of these layers, not a problem at all. And you've got between 0 and 100% of opacity. So you can take it down, make it like a watermark in the train, or have it full on. So we can look at some of the other layers. We've got the bedrock here, 50k bedrock. So there would be a legend that would come with this that would explain to you what each of these colours meant and what lithology they represented. We've got landslide risk, very simple data set, but very important. The darker the yellow, the more risk there is of landslide. Anyway, let's go back to the imagery. Now this is 50 centimetre, so it's a little bit crude, but I've got a bookmark I made earlier which shows where the 50 centimetre joins the 12.5, and there you can see quite clearly the difference between the two data sets. So you can mix resolutions of imagery and layers. You can now put, in the new version, you can implant high detail elevation models into low detail, and the actual edges will all match up. There won't be a problem with that. It's automatically morphed. So you could add the bathymetry of a lake, for example, underneath the land mass, and that would just fit in perfectly. We've got customers who fly UAVs, and of course now the price of these are come right down and the payload greater. So basically you can pick up these amazing cameras now that go on the UAVs, which are picking up incredible data like 4 centimetre elevation models and imagery as well. And we can load that kind of data into GeoVisionary, no problem at all. We've not really found a limit when it comes to the high resolution stuff. And if I fly up, you can see where the line is not color matched across here. And if I fly into the airport, it's quite a big chunk of 12.5. If I fly into the airport, I can come down to the car park. And you can see it's quite a tasty imagery data set. Now the red dot is where we are. I'm going to jump up to Loch Ness, about 350, 400 miles. How quick is that going to be? 1 second and we're there. So the first thing I'm going to do is drag across the train like that, and you can see that we've now got a profile. It's got the minimum and maximum height, distance in a straight line, distance over the train, incline and bearing. The red line is line of sight, and it's red because there's an obstruction here between the 2 points. If I take it like that, you can see now that it's green because there's nothing in between the 2 points. So if you need to know who can see what from where, this is a very good tool. And in the new version of the software, you can do multiple points, and if you have geometry in the profile, then that will be represented as well, whether that's an urban model or a rock volume under the ground. And of course, if you're doing linear projects, you can take this right the way across the country, which will give you a full profile of your road or rail or pipe line that you're going to be laying. And this 3D shapefile can be exported straight into ArcGIS because there is a dynamic link between the two softwares which link the two softwares together, and that enables you to digitize in the 3D window, which I'm going to do now. So we drop down to the coast. What do I want to do? I want to set my drawing tool, and I'm going to set the default properties. I'm going to do a linear that's about 5 meters wide, and I can just go straight down here and start digitizing along the water. And the cool thing is, it's like you've got a jetpack on. You can move around, get the right angle for your line work. You're not doing minus 90 degrees like the bird's eye view. You're actually able to move around totally freely to do your line work. Now I might want to turn on bedrock data again, and I might want to digitize over here, and I might decide, nope, I want to do my tools, but I want my default properties to be a polygon. Change the color, a nice blue, and of course you can attribute everything as you would do if you were doing it in Arc. And of course, once you've built these polygons, you can edit them and change the vertices. You can also pull existing shape files out of ArcGIS into GeoVisionary, edit them, attribute them, whatever you want to do with them, and then you fire them back into ArcGIS. So let's just turn off the bedrock for a minute, and we'll turn the map back on. And what we can do is fly down here. I'm going to turn off the height profile, and we're going to go back to the map, and let's find an area, an outcrop. Let's have a look. In fact, let's go back to bedrock. That might be a better way of doing this. Okay, so this is where we've got the tool called the plane creation tool, and this is where you might have 3 points like this, and you know this is a known quantity because it's been surveyed. It might be a fault, or it might be a seam of gold, whatever it might be, and this enables you to actually extend out these points. And if they were to extend out, where would they go? If this trend was to continue, where would it go? And this enables you to extend out the known quantities that we were looking at there. So it's a great way for doing that, and it's something the geologist requested was actually part of the tool. So let's just go back to the bedrock data and just turn that off, back to imagery, take the OS back. Remember, you can have as many layers as you want on these. We can take a spin along Loch Ness, flying very smoothly. Beautiful scenery. You never quite know what you're going to find when you're flying around the UK. See what I mean? That's how special the software is. We're going to jump down to a mine now. This is about 400-mile jump to the mine. Boom, takes about 1 second. And you'll see that these models of these trucks are actually proper cab models, about 1 million triangles each. You can get inside there. And this is one of the few open cast mines you have left in the UK. This is a clay mine for pulling out the clay for the fine bone china for our cups of tea. Now we might want to start looking at underground data here. So if we come back in the air, there's different ways you can do that. So the first thing I'm going to do is turn it on. And got a few more here. So there's different ways we can do this. The first way is we can turn the ground off. And we can do that quite simply by doing that, making it completely disappear. We move in, you can see the underground data, and we can bring it back to this nice level where it's on about 30-40%, which means you can see the underground data but also see the ground at the same time. This is a really nice way to fly if you've got a lot of underground data. I see a lot of people flying using this method. Or of course we can make it completely opaque and we can just go underground. So this is a great way of looking at something and doing something you can never do in real life. So you can interrogate any of these 125 metric ton blocks, look at the additional data in the bottom left, and you can see all the precious metals and the percentages in the block. So when the mining company are going to be building a new shaft, they can actually calculate with these blocks the return of investment, how much precious metals they're going to pull out the ground from their seismic and magnetic field studies and of course their boreholes. But again, this is just a great way of showing something or demonstrating something, especially if the person you're showing is not an expert, is not a scientist. So it could be a CEO, VIP, stakeholder, or the general public. This is a great way to show something in a way that people are going to get, and they're going to understand it, and they're going to appreciate what you're showing them without being confused. Staying underground, let's go and look at some boreholes. So we're still under the ground looking up. These are boreholes from under Nottingham for coal. The discs represent a change in lithology and they've been marked on the train by that derrick. And we can see different data sets here. You've got geological cross sections, you've got the boreholes, and you've also got these orbs which represent 50 years of historic seismic activity in the UK. So the BGS have got 10,000 sensors around the country and they pick up the seismic activity. As you can see, we're not in a bad situation when it comes to too much seismic activity. We're not exactly on the Andreas fault here, but you can see there are lots, little and often. But a way this is actually showing you is all these different data sets together, geospatially referenced, so you can understand the relationship between them. And in the new version of the software, you'll be able to measure between all these softwares. It's not a problem at all, and everything you have loaded in here can have a hyperlink. You can hyperlink out to external information such as a web page, a movie, a pie chart, a report, a folder of photographs. You can do that on every single object that's in here. Okay, let's go and do some flooding. So here we are in Norwich, and what I've done is I've loaded a red cube, and I've taken that red cube and I've expanded it out in 2 planes, so it makes it like a big red sheet. And I can just turn some of this underground data off for a minute. So I think it's that one there. So at the moment we're at -2 meters. As I bring it up, -1.5, you can see it coming through there. -1, the lowlands are filling up at the top of your screen. -0.5 meter, you've got this area here. And then at 0, you've got the football ground, good old Carrow Road getting flooded. And if we bring it up crazy high, we can bring it right up here. Because we know that when these floods happen in the UK, and they do every year, people get rescued and they get taken to a sports centre or a school gymnasium. And what's happened before in the past is that they've taken them to a place of safety, and then that's flooded because it's still in the basin, and they've had to move them again, which is, you know, twice the effort. It's upset the people having to be moved twice, and it costs money. And so now, if we were to bring this up like very, very high, you know that at the end of the day, this area to the left and this area to the right are going to be safe. They're on the higher ground, and that would be the place, excuse me, where you'd actually take these people. But something else this can do, it enables you to actually compare your data sets. So I can go to the flood indicators here. This is 50 years of historic floods. I can turn it on, and you can see now, if I go back to the cube and the location, I can take this down, and you can like compare the data, and you can actually fit it to actually see it was at the right level of the flood that was recorded. So yeah, it's a great way of looking at your data in a different way, in a different, you know, have it all stitched together in one great big sheet as well. And quite often our customers will find when they put their data sets together that they have to fix them. So there's quite often mistakes because they've not seen their data on this particular scale before. Okay, so let's go down to Stonehenge. So what's been going on here is that for years these cars have been driving past on this road here, and the fumes from the exhaust have actually blackened the stones and beginning to affect them. And Stonehenge is pretty dear to the British people, so that they were talking about building a tunnel under here, from here to here, to protect the stones, and it's taken many years to get this done, but it's finally been approved. So the stones are going to be protected. The thing I don't fully understand is why they built Stonehenge right next to a busy road. Obviously they didn't plan that really very well, did they? So what we can do now, we can go into London, and we can go to Chelsea. And this is an urban area from our friends and partners at Vertex Modelling, who have pretty much built every building inside the M25 motorway. There's Stamford Bridge, Chelsea's football ground, and here we have good old Earls Court, which is not there anymore, and the Metropolitan Police headquarters. Now, if we have this thing in the UK called blue sky tax, where if you take away someone, if you build something and it takes away someone's blue sky, you have to pay them. And also, if you put them in shadow, you also have to pay them. In the new version of this software, you can create a dynamic shadow for different times a year that show you who you're putting in shadow and for how long, which is very useful. And also, say for example, this building here was going to be the new project, and there's going to be 5,000 or 10,000 trucks delivering the raw material. How do we get them in? Now, unlike America, with your nice big wide roads, the roads in London were built for horse and carriage. So, you know, are we going to get these great big 18-wheeler, you know, HGVs in here? We need to get them in the best way, without having to close roads, without upsetting the local residents, so they can get in, lose their materials, and get out in a safe way without actually coming head to head with an oncoming truck. So this is a great way of doing this in the planning stage, where you can plan the route in. You can also, as I'm flying around, I could be recording all this, but you can do it free flying, or you can do it by putting points in certain places, and it will follow the points. And that is a great way of recording a route if you need to get in and out of somewhere, and you can see actually what it's going to be like, you know, for the trucks as they come rumbling in, and which route they're going to take. Something else you can do with this is what are the public going to do about their view. You can take them in, you can a public address, you can show someone their bedroom and say, this is your bedroom, this is the view you're going to get once this has been built. So it's a very great way for seeing how people's views are affected by developments. So let's go down and look at power station. This is a power station from Australia, and let's just move in a little bit better here. So we can fly down to the power station, and as you can see, this is a full-on CAD model. This is out of DGN, or sorry, out of micro Bentley station, DGN via PDMS, I think. And you can see this is a full-on model. Everything's there, every nut and bolt. 68 million triangles on a single level of detail. You'd never be able to load this kind of model in the original CAD package, and quite often when designers see their CAD model in its entirety, it's in GeoVisionary for the first time, because they can't just load it like this in their native packages it was created in. Beautiful way to be able to move around and fly. And of course, if you had something like this, it would have new car parts, new roads, new pipe networks. And if you had these modeled, you can just add these in as well. It's just a great way of looking at something before it's been built, just to see what the effect is. So if we take these people down to their house here, a bit sad, but yeah, there's their bedroom window, and this is what they're going to look at. I wouldn't be too happy personally, but again, it is a great way of seeing how something affects the landscape. Of course, you can measure across the terrain, measure between objects, see what the distance is between them. So let's go and look at a quarry. So there's a bookmark I made earlier, and we're going to turn on a point cloud. So this is one of the first softwares where you can load massive point clouds with the rest of the data.